Good morning to all my smart and amazing students. So today we will do how to solve real life problems through mathematical modeling. Yeah, so our aim for today is we'll apply mathematics in problem solving. Yeah, okay, and here you'll get the following function. Your mathematical modeling will involve the following function. When you do the research and you get your data, most of your data will be presented, yeah, in a graph form, in a function, and it can be in linear form, in quadratic, or exponential. Yeah, so for linear function, the graph will be, of course, a straight line. Yeah, you still remember straight line. Yeah, and it will be, if it is like this, y equal mx plus c. Yeah, this is your c, your m is your gradient. Yeah, and your graph can be like this, and it's a straight line. Okay, for quadratic function, you'll have a curve in a form of parabola. Yeah, and then the curve may rise and then fall, or fall and then rise. You still remember? Yeah, the smiling and the not smiling graph. This one or this one. Yeah, that is the quadratic function, and the function is, still remember, ax squared plus bx plus c. Yeah, bc is a constant. Okay, for exponential function, okay, it's a curve graph illustrating an increase or decrease in values of data in a sharp rate. Exponential, in a very sharp rate, that means very fast growth. If it is increasing. So the function is like this. Yeah, y equal ca to the power x. So x actually is the exponent, is the exponent, and c and a is a constant. Yeah, it's a constant. It can be any value except 0 lah. Yeah. And then, for example, yeah, y equal 2 to the power of x. So your c is 2, your a, your c, sorry, your c is 1, yeah, and your a is 2. Okay, you can see lah, 2 to the power of x. If 2 to the power of 1, it is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. See how big the number change? 2 to the power of 4 is what? 16. Yeah, 2 to the power of 5 is 32. So it very fast. The data increase. That's why it's called exponent. Yeah, exponential function. The function of y equal 2 to the power of x. The graph will be like this. You can see how fast the value of y increase. Yeah, it's increasing exponentially, and the graph cannot go through 0. it must pass, if for this function, it will pass 1, yeah, because when x is 0, your y will be 2 to the power of 0, then your y will be 1. So that's why it start at 1 here, yeah, and it will never start at 0 for exponential graph. Cut the y-axis, and it can be the other way. If your x is negative, the exponent is negative, so your graph will be like this, yeah, just the opposite. This one when your x is positive, yeah, the exponent. Okay, look at example 2. Amin travel 405 kilometers on 45 liters of petrol in his car. If Amin wishes to go to a place which is 198 kilometers away by car, how much petrol in liters does he need? Solve this problem through mathematical modeling. So, you have to use all the components. The first one is the big I, that is identifying, yeah, and defining the problem. So the first one, what is the problem? We define the problem first. Okay, problem is this one. It's in the question, yeah. You are asked to solve what? Okay, I mean wishes to how much petrol, yeah. How much petrol needed? Okay, is this enough information? How much petrol needed? Can we be more specific? Yeah. How much petrol needed for what's the distance? Yes, 198 kilometer. You want to know how much petrol needed for 198 kilometers. So that is the problem. Then next, what you know? What do you know? You know that the distance travel for 405, yeah, will need 45 liters. This is kilometer, right? So we can simplify it. 405 is the distance and 45 liter is the petrol. Okay, can we find the relationship between the distance and the petrol used? Okay, when the distance increase, of course petrol also will increase, yeah, or vice versa. If petrol increase, distance also will increase. Yeah, when more petrol used, it shows that the distance also will increase. Okay, so you can say that what you know is, remember, there is a term for that. When one quantity increase, the other one also increase, you say that the distance varies directly with the petrol. Yeah, remember, varies directly. Yeah, so if you want to see, the answer is, we know that the further we travel, the more petrol we require. So the amount of petrol varies directly. See, the amount of petrol P varies directly with the distance. here. Where is directly? The symbol is, you still remember the symbol? Yeah, this one, alpha. That's why we can say that P varies directly with D, or distance varies directly with P. No problem for that. Okay, so the second one is you are making assumption, yeah, making assumption, and then you identify the variable. So what do you assume? Okay, you assume that the driving speed, yeah, for both the routes, yeah, are the same, yeah, because we are concerned about the petrol. Because if your speed, yeah, your speed is high, your petrol also will be consumed more, yeah. When your speed, you constant speed, so your petrol also will be constant. The same amount of petrol will be needed. So we must assume that the driving speed, this one must be the same. He cannot go fast here and then slow here, because the petrol consumed will be different. Okay, so the variables, now we go to the variables. Variables, you just check in your, when you identify, you know already your variable. So the variable will be, here we have already talked about it, will be the distance travel, yeah, the variable will be the distance, and then the petrol, yeah, petrol. So we can make it in a form of relationship, yeah. So D varies directly with P, and you can say that your petrol, you can say that this is your Y, yeah, and your distance is your X. So X varies directly with Y. Or if you say petrol varies directly with your distance, so your Y varies directly with your X, yeah, up to you. So here your Y is your petrol, your X is your distance. So this one, you remember, X equal, you want to change it into equation ky, and then this one Y equal kx, yeah. So for this example, it this one is used, yeah, Y equal kx. So you just substitute your petrol here, yeah, this is your petrol and this is your distance, to find your k, yeah, you must find your k first. So you just substitute it, and your k is 1/9. So you substitute back. I hope you still remember our direct variation. Okay, so this equation describe the relationship between the amount of petrol, yeah, petrol, and the distance. And distance we say x, and this one is y, right? So now you can find lah. Now your distance is 198 kilometer, right? So you want to find your petrol needed. You have your K 1/9. You just substitute, yeah, substitute it into here, and then you get your Y. So Y is 22 liters. So hence 22 liters of petrol is needed or required to travel for 198 kilometer. Yeah, so you have apply, yeah, this part is the third one. You have applied the mathematics to solve problem. Okay, then you want to verify, yeah, you want to verify and interpreting the solution in context of the problem. Okay, why we may not be able to use the linear function model, this one? Okay, because for in the real world, yeah, the 405-kilometer route is through towns and cities. It's not just a straight line like that. Yeah. So if through city and town, you will go maybe the direction is like that. It's not the straight line like that. If it is straight line, yes, you can use this function. Yeah. Maybe this is the highway. Yeah. Maybe the 198 kilometer is the highway. But the 408 is maybe the route is like this. Who knows? Yeah. So this function is not applicable anymore because the car will use up petrol faster in the first route compared to the second route. This is the first and this is the second. When this is translated into the real world situation, the linear function model obtained is not suitable. Yeah, not suitable. Real world is too ideal. Just now we talk about. So we go to the fifth component, refining the mathematical model. In this problem, we are not able to refine the model due to this one. Limited information given. You can use this term, yeah, next time if you find the same situation with this example where it is not practical in the real world. You can use this term. And then the sixth component is you report the findings. So this statement normally will be standard. You can say that report the findings of problem solving based on the interpretation of solution as shown in the preceding section. So you memorize this. This is the format how to report. Yeah. Okay, for Ray robot, yeah, the fifth and the sixth component, there are sentences that you have to use format. Yeah. Okay. So that goes example 2.